Yes, good morning, everybody. It's per itinerary, 10:05. We've got how many people today? 55 people. This is a good turnout. We're going to start with a pumping webinar. I'm here with my colleague Chris Liepkot. My name is Luis Perez from Easy Power. Thank you very much for making the time today. We're very grateful of your attendance to the webinar. There was a very large number of people that actually signed up for the webinar, on top of 200 people. So some will be signing in and out during the course of the meeting. All the materials that you will be presented today, plus a few more guides, will be emailed to all the people that participated on the meeting, right? So without any much further introduction, Chris is going to actually take us through the meeting today.
Morning, guys. Chris here from Easy Power, Chris Liepkot. Okay, so let's get going. So we'll start with the solar pumping inverters. There is a disclaimer there in front there. I'll give you guys a couple of seconds just to go through it, just to familiarize yourself with our terms and conditions. All right, when you guys are ready, you always go back to it. It'll be emailed to you anyway, not a worries. So the usage of the VSDs, we can use it for domestic uses. So for your normal pool pumps, your bore pumps, a lot of guys have got koi ponds that they want to use. We can use it for that. You can also use for municipal. So if any of the guys have got tenders going on to work with municipalities or with government, if you do want to do irrigation to pump up to big tanks or big towers, you can do that as well. You can definitely do that. The big thing I think everyone is waiting for is on the agricultural side. A lot of guys are doing pumping for growing crops, for farming. So that's a big thing here on the agricultural side. We can do that from anything small, single phase, up to big three-phase, 100 to 200 kilowatt systems. So that's not a problem for us. We can definitely help you guys with that. Desert countries, obviously up in Africa where it's very, very dry, where there's no electricity, we can definitely help you out there as well. It's all easy where there's no AC to be helped. Forestry irrigation, same thing. No electricity or no AC. You can put up a nice VSD system up there. If you can incorporate the generator, great. You can run for about 24 hours a day, not a problem. Cattle watering, again, like I said earlier, agricultural and cattle. Farming, that'll be a great thing. But we'll go through all that today, guys. This is just a small overview of what it could look like or how do we put the system together. So you've got your solar panels going into your GD100 or your little module, your VSD. You can also incorporate AC into it. So if there's not enough solar, AC can kick in and run it. So that'll go down to your pump, and then you can pump that directly to a tank, or you can pump it directly to your irrigation, all depending on the capability of your pump that you have. So the only thing we're changing here, guys, is the supply to your pump. We're not generating or making your pump go a lot faster. We're just making your pump run from DC instead of AC, saving you guys a lot of money. Okay, so here's the pumping concept, so what it actually does. So what the VSD or variable speed drive or variable frequency drive, like guys call it, it just changes the frequency and the voltage of how your pump starts. So what we'll do is we'll take DC power from solar, we'll convert it through the inverter to AC and run your pump. It'll start at a lower frequency. Instead of 50 hertz, we'll start at about 37 hertz and can ramp it up to 50 hertz to get the optimum out of your pump through the day. That's what a VSD basically does. It just takes DC power, converts it to AC, saving guys electricity. If there's not enough PV during the day, it'll pick up at 37 hertz. If there's not enough power from the PV, it'll wait 5 minutes, restart, and try and start up again. And it'll do that concurrently for every 5 minutes, which is a preset time you can do until there's enough frequency or voltage from the panel to start up your pump. Alternatively, if there is not enough for that and it is a very cloudy day, you can use AC. So in cloud conditions in the middle of the day, you may allow the pump to run for less, obviously. So you can use the AC instead of the DC then. It's just very cloudy days and you do need to pump. Alternatively, you can use the generator as well if that's the issue there.
some models have automatic changeover. So as the frequency drops below the cutting point, in this case 37, it will switch over automatically to any available AC source. Okay, we'll discuss that later.
Okay, so again, what is a pump VSD? So again, it's just like I explained to you guys earlier. It'll convert power from DC to AC to run the drive the motors. Okay, so the process uses well-known IGBTs with a PWM bridge to give you a steady AC output to the pump, not to damage the pump. So in order to maximize the amount of running hours during the day and minimize the size of the PV array, the real speed drive is part of the pump inverter. The VSD can curtail startup current by slow pump acceleration. Again, it won't damage your pump. It'll start it at a low frequency with low voltages and ramp it up during the course of the day to get the optimum out of your pump. So whether doing that and the clouds coming in and going, if you're worried about that damaging your pump, it won't do that. It'll run it at a certain frequency and certain voltages, not to damage your pump. Here's just a little calculator that we put together for you guys. This is just a screenshot, but it will be emailed to you as well to run out, to work out the amount of hours you guys want to run for the day. So theoretically, in Africa or in South Africa, we have about 5 hours optimum running or optimum radiation through the day. You can maximize that by overpanning on your VSD to start your day a lot earlier to make it run a lot later during the day. Alternatively, a lot of guys want to run for maybe 24 hours a day and they want to incorporate batteries. It's not an option that we would recommend because batteries are quite expensive, but you could do a tank based on a hill or on a stand and pump enough water for your usage for the 24-hour period that you use. So put a big enough pump in to run and pump exactly the amount of water that you need for a 24-hour cycle to a tank, and you'll be able to drip that or to drip feeders or to do gravity feed directly from the tank.
Here, interesting is to see the variables of this chart, which you will receive the Excel of that. The amount of day hours per day actually do change during the year. Having in summer much longer days and having in winter much shorter days. So is as well the PV production of your solar array. In this graph, blue is essentially the available power from the solar array, and orange in this case is the theoretical one-to-one consumption from the pump. Assuming that the pump inverter manages to do a startup of 1-to-1 ratio, right? So it requires 1,000 watts to start a 1,000 watt pump. So you can see that the bigger we make the blue curve, the more hours under the blue curve we will have to run that orange load in this case. So typically it is very easy to obtain 5 to 6 hours of pumping per day from a PV setup with a reasonable amount of PV, but that can be extended considerably. You can go up to 10 hours per day of pumping if you add sufficient additional solar panels into the installation. So amount of hours per day, it's proportional essentially to the amount of PV available, right? So here we have a case of a borehole. So we have to be cognizant that these pump inverters can be used for all sorts of asynchronous motors. So that can be your swimming pool pump, that can be a borehole pump, or that can be a pump just centrifugal pump just pumping out of a river, for example, a catchment area. The difference is the amount of height that the pump has to pump against. So in the case of a borehole pump, you can very well have your pump to start the motor early on the day, like in that example. Let's say by 9 in the morning your pump is running, but it's not running at maximum power. Therefore, it's not able to actually obtain enough height to actually show any water coming out of the borehole. In this example, that water will only be visible, or the water being pumped out of the borehole within a narrower section of the day. So again, because the pump inverter can only produce the amount of power that is supplied by the PV, in the case of a submersible application, you need to have more PV than what you have in a surface pump application. So surface pump application where you're just transvassing liquid from a reservoir to a tank with low height, in those first hours of the day, you will have some water actually coming out of the pump because the pump is working against low head. That's not going to happen with a submersible pump. So to avoid disappointment, it's important that submersible setups do have enough spare PV capability so you can have water from early on the day.
Again, like we touched on earlier, to run a 24-hour cycle. So all VSDs have got an AC switching capability inside them. So they can run from the sun directly for the 4 to 5 hours or 6 hours, depending on where you are in South Africa or in Africa in general. You can also incorporate AC. If there is no AC, obviously a generator. Again, like I said earlier, if you do want to run a 24-hour cycle, we do recommend you put in a big enough pump, and hopefully your hole can supply enough water for the 24-hour cycle. You can pump it to a tank or to a reservoir, and hopefully gravity feed from there to drippers. If you do need high pressure irrigation for the nighttime, then you'd have to put on a pressure pump for that, but that'll obviously run from AC or diesel generator. But again, your consumption or your cost at running that will be a lot less than running a PV system.
Running a battery system.
Sorry, a battery system.
Running a battery system to the same approach. So examples of elevated storage. You can have physically a metal tank, 10 meters high. You can have a reservoir which is built on the top of a mountain, a copy, to which you actually pump your water during the day, and from where you actually drain your water 24 hours a day. So that's two good examples. Okay.
So here's just the difference between the solar pump kits and then obviously running it from a pump, from a diesel generator. So you can see the cost, the operating costs or the initial outlay on the VSD system will be a little bit more understandable. You can see that on the left-hand side compared to what the generator cost will be, the initial outlay. The overall maintenance on solar power, you have to clean the panels once a month. That's basically it. Take a mop, you go out there and you clean the panels. As long as they're clean, the efficiency will be great and you'll be able to pump as much as you want. Obviously, just check the wires and check as much as you can. You can also see the operation or the maintenance on the generator side. Every 250 hours is a minor service you have to do, which is a cost involved. And every 1,500 hours is a major service, which is a big cost to get involved.
I think the bigger cost there is the diesel, which accrued over such a long period of time. It adds to a very big number, very big value. As well, the reliability of a diesel generator remote on the field. So these inverters tends to be a lot more reliable than a generator kept alone on the field, so they can work on their own. Especially now, we're going to show you guys how the remote monitoring works, which is something that you're actually not going to be able to do easily with a generator, which I think is actually the tipping point for me with regards to pump inverters.
So these are just the different models that you do get. You've got the Good Drive 100 series. These go from anything between a 0.37 kilowatt single phase, and they can go all the way up to about a 200 kilowatt three-phase big systems. The BPD series, those are more just on the single phase. They do look a bit different. The BPD series is more of an IP65 box. It works up to a 2.2 kilowatt on the single phase, but it's got everything built inside it. It's got a booster, it's got AC switching on it. It can be put out in the field wherever it is, and it's literally a plug and play unit. Very easy to use, very easy to set up. So these are the GD100s, the scalable options. So you'll see on the little one on the left-hand side, it's got a little screen on there with little buttons. You can set up all your parameters of the inverter or your little pump VSD. The right one is more for the bigger systems, the 5.5, 7.5s, etc., all like the big ones. That little monitor can actually be plugged out, and you can set it up and just plug it back in as you need. So they all come with a PWM control unit inside. AC switching function between the two inverters, and then the models up to 2.2. So the PV booster is optional on these systems, but it goes in for the single phase units. So how that works, and I'll show you in the next clip, is that the PV booster, if you incorporate it into your VSD, you need a lot less panels. The guys are always worried about putting a lot of panels up in a remote area because of theft, but by incorporating a booster into your VSD, a lot less panels are needed to start your day a lot earlier. Also, the booster has got an INVT and the lowest starting voltage. So instead of needing 200 volts to start off for the day, it'll need about 80 to 100, and it'll start pumping a lot earlier in the morning because it'll go from 80 to 100 volts and boost it up to 400 volts to give you a longer day as well. So a lot less panels needed, a lot more cost effective. Okay, this is just a couple of things why the GD100 was developed. So there was a lot of different models on the market from the GD100 or GD series, and the guys just felt it was just too much stock to be kept on hand because we had different models and different this. We're trying to incorporate everything to be the same. So previous versions, you can see there, the motors of GD auto set critical motor parameters.
This is an important one because for the ones that have not experienced using this GD100 or the BPV, Previously, you had to have intimate knowledge of electrical parameters on the motor, which most times are actually not even available on the motor data plate. So at this point, the only thing you need to know from your motor, if it is single phase or three phase, and what size of motor it is. On the very first start, the inverter will run actually a diagnostic and will calculate all those electrical parameters from the motor, which is awesome. Correct. So this is something that is a quantum leap with regards to ease of use of these inverters.
Okay, so there was a big failure rate on the earlier models on the inverters or IGBTs, but it has improved and changed the stability of these good drive inverters. Hence the big warranty we can give down on them. Okay, so just a bit of advantages of what the DD100s can do. You guys can run through that, but I'll quickly give a little breakdown of it. It automatically starts up when there's obviously enough solar panel or enough PV or voltage for the day. So it'll automatically start up. And minimal parameter settings again. Luckily we said it's a plug and play type of unit. There's minimal parameters you can set up to get the thing going. Obviously compatible with the boost unit or the boost module. You can implement the auto switch between PV and grid. So obviously to do the automatic switching by itself. It can do single phase motors, three phase motors, 2 wires and 3 wires. The GPRS module can be incorporated into any of these units. So you can remotely log into your pump, go see what's actually happening. You can start and stop things, you can change frequencies, you can see what it's done for the day. We'll go into more detail with that now, but we'll have a look at it. Also, there's an IP54 cabinet solution. So we can actually incorporate everything into a little cabinet for you. Your VSD, your booster module, your GPS, with your surge protection, all the plug and play unit, you take it, you plug it in, and you're good to go. So these are just the different ranges that we can get on the DDs. So you obviously get your single phase 220 in, 220 out. You get your single phase 220 in, 3 phase 220 out, 3 phase 220 in, and 3 phase 220 out. And you've got 3 phase 380 and 3 phase 380 out. So
with regards to AC in, AC out. So you can cover, especially the first two, it's covering certain niche market of submersible pumps that actually will require that. Okay. So especially the second is quite handy for some small 3-phase pumps when you only have a single phase supply of grid supply, which is great.
Okay, so on top here you can just see the nameplate of the pumps. It'll say GD100 with a dash, with a product code and what it can do. So each item that you can see the 1, 2, 3, 4, 5, it'll tell you below what each digit or what each little underlining mention there means. It'll tell you exactly what it means there. It's just more for name with the nameplate and when you're ordering your system as well.
For ordering purposes, to understand what the model number means, correct?
Okay, so here's your starting voltages of the different pumps. You'll see you've got your SS2, S2, your 2, and then your 4. Your 4 will be on the 3-phase, the 2 will be 223 phase, and the SS2 and S2 will be single phase units. So you can obviously see there, your DC starting input voltage will be between 200 and 400 volts. Okay, and then on the 3-phase ones, it'll be 200 to 400 on the 220, and 300 to 750 on the 3-phase ones. If you incorporate the booster module on these, obviously your voltage will be a lot less that you require.
Which is relevant because you can only work on a round number of strings. So you might throw an extra half string just to be able to have enough panels per string to match your configuration. So a PV booster is a great improvement, improvement to a GD100 and a great improvement fixed into a BPD.
Just a little standard wiring kit of how it could be wired.
Very simple.
Again, very simple. Again, very simple, like we said. You do have different options.
Correct. So you have different options. Well, as we, it presumes that it's going to work with a water pump. So therefore, it has actually 2 sensor inputs, or what they call a digital input. So the pump inverter is able to sense if the ball pump or the pump it has a dry condition. So in other words, the ball is dry. So that is connected via the S3. And via the S2, we can actually tell the pump inverter to switch off the pump if the tank is full. So essentially, if left to work in automatic, the pump inverter will work in between full tank and dry well, and in between any of those considerations. And it will start randomly as the level on the tank goes below the minimum value for the sensor to open. And the same thing will stop as the ball pump dries up the well. Okay. Then, For three-phase pumps, not too much of a complication because three-phase pump is very simple to wire. Single-phase pumps, especially with borehole pumps, you can have two categories. Some of them, especially multi-stage, they require a very high amount of torque to start. And because of that, you require startup capacitors, okay, and running capacitors. Some pump inverters might have challenges starting them. So therefore, the pump inverter comes with a mode, a special mode, to be able to deal with a single-phase pump that requires a three-wire configuration for start. So typically, you have U, V, and W. Most pumps will start with U and W, but some pumps will require U, V, and W. So in that case, we need to actually physically short two contacts, S4 and common, which is going to tell the pump that we're going to use all three contacts to actually start the pump, right? So it's a little bit better in the next slide. What you can see here on the left, sorry, I think we missed two letters there, the letters of the contacts. It should be U on top and W on the bottom. But you can see that you have your two capacitors, C1 and C2. So in essence, what needs to be done if you have a pump that do not want to start by connecting U and W, you need to actually bridge S4 and common. And in your pump, you need to remove C1 and C2, those two capacitors, and connect directly U, V, and W on the right order from the pump inverter into the pump. Now the pump inverter will take care of pushing power through U or V, depending on which time the startup period is the pump going through. Because the pump inverter knows the frequency, and the pump inverter can estimate what is the power setting and speed of the pump. At every point of the ramp up, the pump inverter will decide when to send current to U or when to send current to V. All right? So essentially, it's working like a startup panel on these single-phase pumps that require all these capacitors. But the capacitors have to be removed
in order for it to work.
In order to work optimally, correct.
So again, here's the onboard keyboards, which I touched on earlier. Like I said, it's the little one on the left. It's not a removable one. You're going to physically have to touch or just set up everything on the little keyboard there. On the bigger unit, you can detach that. If you're going to build a cabinet, you could actually run a cable from that little unit to the VSD on the inside of the cabinet and put that little keypad on the outside of the cabinet if you really want to do that. If you don't want anyone to be opening it up and playing around. But alternatively, you can just plug and play and take it out, set it up, and plug it back in. Not an issue.
Correct. Okay, so for some applications, since the pump inverter is an inverter after all, it does produce a certain degree of electromagnetic interference, electromagnetic noise. Depending on a series of conditions, as the inductance of the cable between the pump inverter and the pump, and depending on the shielding of the cable itself, you might want to actually do some filtering of the power going out of the pump inverter into your pump. In order to do that, there is a built-in set of capacitors which can be used on demand via a jumper, the jumper J10, on some of the larger models of the three-phase pump inverters, which comply with the category C3 filters as per the IEC 61800-3. There might be supplementary filters which might be required to still operate optimally your pump, depending on distance between the pump inverter and the pump, and depending on the caliber of the cable, which we're going to touch later. But this is a built-in function which is well documented on the equipment documentation manuals.
Okay, so there's the PV switching module. So obviously, again, if you wanted to switch between DC power from your solar panels as well as AC, you can just incorporate this little switching module, which can actually do that automatically for you. So again, not enough PV or not enough voltage from the sun, it'll automatically switch over to AC. AC will run the pump. When there's sufficient enough voltage, the panels will kick in again and switch off the AC side.
So in essence, the switching to AC is all based on monitoring the PV voltage available from the solar array. So this is happening dynamically, either for startup or either for keeping the pump running after the pump is running. Because you can very well be running your pump and you can have a cloud just to come right on top of the pumping station. So this is an additional board which is not built in on certain sizes of inverters. It needs to be acquired, purchased additionally, okay? And it gives a signal to the GD100 inverter to control a relay, which you can see there, KM1, which is driving a contactor. The contactor is the one that is bringing the AC into the pump inverter, right? So the pump inverter cannot work with AC and PV simultaneously. It has to work either or. So whenever this relay is activated, it discontinues the production of AC from the solar supply. So at such point that the voltage goes over a certain point, which is a parameter setting, the voltage detection circuit will go and open that relay. The relay will open the contactor, therefore now the power will come from PV. And this happens dynamically the whole day as it's switching between AC and PV. Since your motor has certain inertia, you never quite stop pumping. Okay, typically the motor will not decelerate that quickly on this changeover, but there is a changeover time.
Yeah, it's milliseconds of it, yeah.
So here you guys can see the switching module, okay? So it's an additional...
there's a little board with some heatsink on it.
Correct.
It actually goes into a box.
It's a logic board that actually is measuring the PV voltage, and it goes as part of the installation when you actually buy 4.4 kilowatts of the. So now, how to select the number of panels? Well, the good news is we got this all worked out for you, and we've got tables from which you can go and select, which we will be issuing to you as per your registered email addresses. So there's no need to panic about that. It's just important to understand a couple basic concepts of solar power in general and solar power applied to this pump inverter. There is two things that we want to achieve. We want to make sure that the pump inverter do not break because we have connected too many panels in series. In other words, our open circuit voltage of our solar array is higher than the maximum that the pump inverter can support. And secondly, we want to make sure that when is the hottest time of the day, when we're pumping a maximum capacity, it's right about 12 to 1 p.m., we don't have too low voltage and then the pump inverter stops. So considering that the pump inverter has a maximum power and power point that is suggested by the manufacturer, all the string configuration is done around the maximum power point. Okay? So for the first three models, SS2, S2, which is single phase, and 2, which is three-phase, they talk about an input voltage to the pump inverter from the DC circuit from the solar panels of about 330 volts DC, which is quite high. When you think that you have to make that number using the maximum power voltage of your panels, assuming typically anywhere between 30 and 36 volts, it might take more than 10 panels to actually achieve that per string.
Yes.
Okay? So it is important that always when you do your calculations to know how long your strings are, you use the maximum power voltage of the panel adjusted by temperature. Okay? Remember, temperature is going to want to steal about 13–14% of your panel voltage when it's really hot in the middle of the day. So based on that is that you will be able to calculate essentially how many panels per string you require. Now, how many strings is a different story. As we discussed a few slides previously. The more power we have, the more hours of pumping we're going to have during the day at full maximum power, rated power, if you will. So the minimum recommended is 1.5 times. But depending on your application, you might end up on 2 to 3 times the amount of PV panels.
All that will depend on how deep your hole is, how far away your VSD will be from your pump. All that kind of stuff plays a big factor into how many panels, what size VSD you'll need. You might have to replace your cabling if you don't want to go for a lot bigger VSD with a lot bigger panel array. So it's all dependent on your certain application that you're going to use it for on the day.
Correct.
So
we do have tables that actually give you a safe configuration of string length. So you know that you need a string of, let's say, 10 panels of a certain specification. But then how many strings you need is a different story. Because that depends on the amount of hours per day that you require. It depends on the losses on the cable as well that you have. It depends on what filters you have in the output. Also,
the calculation that we've done that we will supply to you guys, it's also based on the maximum amount of hours a day. You can go with a few little or less panels to get 2 or 3 hours if that's what your pump is, if you're happy to do that. You can put in a lot less panels, run for 2–3 hours, and then that's it. You get your peak, it comes down, and then it switches off. If you do want to run predominantly off the PV or off the VSD, we do recommend you putting the maximum amount of panels that the VSD allows to get your optimum amount of run hours a day. So you're obviously saving a lot more on ESCOM.
Correct. Okay, so this is very much the same thing, but just now in better detail and just introducing a new piece of equipment, which is the PV booster. So if you see at the bottom of this slide, you will notice that we are talking about the starting the voltage range for the different models, and you can see how much less voltage is required to start the pumps when we actually have a booster on the circuit. The booster is an additional piece of hardware which essentially boosts the voltage from PV from a low input as low as 100 volts to 400 volts minimum. And 400 volts minimum, as you will see on the section we run PV booster, will pretty much start any of the inverters on the SS2, S2, and 2 category. Okay, so a PV booster is limited to only single phase, less than 2.2 kilowatt applications. Okay, so but it's a very good, useful tool for small systems to actually try and reduce the cost of those small systems. Okay.
Again, the cost of the PV booster will be less than adding all the additional panels. It's not a big cost on the PV booster. It's not astronomically expensive, but it is a lot cheaper than putting in a PV booster in addition to adding the panels or the additional panels you might need.
Correct, and you have to consider that when you add additional panels, you add additional mounting structure, probably a bigger pole, more wiring, more protections. So there is a compound additional cost, not only the panels themselves. Okay, so this is how
this is what the booster looks like.
The booster looks like this.
So there you can see the maximum input kilowatts will be 3.2. Obviously, the maximum DC power that it can take is 600 volts. The minimum that needs to start up is only 80 volts, which is significantly a lot less than what you need without the booster. And obviously, like we said, it'll only be for the single phase units, up to 2.2. But you can put in 3-4 panels, start running your day. Obviously, you'd have to wait for the right amount of voltage to start up, but it will definitely start up, run for a couple of hours, and come down again with a lot less panels.
Very simple configuration of PV booster. It doesn't require any additional configuration on the inverter. It's designed to be plug and play. So essentially you connect your PV on one end, the output, which is a boosted high voltage output. You connect it as the input of your pump inverter. And there is four wires that have to be connected for the serial communication between the GD100 and the boost module. So it's extremely simple to use. You can see a picture there on the top right. That's how it looks in real life.
So there's your GD100 or your VSD on the right, the boost on the left.
This is an example into which we are looking into how many pieces per string will require to run a specific pump. So in this specific example, we are actually saving 4 PV modules. We're talking about voltage here. We're not talking about pumping hours per day. We're talking about the minimum amount necessary to get the pump to start for a minimum amount of hours per day, essentially. So the PV booster does a great job on reducing the amount of required PV. As you can see, it goes from 15 to 11 pieces.
This is just a pre-assembled option that if you wanted to go this route, we could do something like this for you guys. We could pre-assemble everything beforehand, do a little plug and play type of thing. So you'll see on the left-hand side there, far left, you've got a GPRS module, which you can link on and synchronize with your phone, see what's happening with your system. In the middle there's the booster. On the right-hand side, that's the VSD units. On the bottom section there, you've got all your surge protection, your fuses, your isolators. Everything is incorporated into one. Your AC breakers there as well, you're incorporating AC. And on top there, you've obviously got a fan for the ventilation. Some of the guys put this out in the field. It can get very hot, which will drop the efficiency.
It's essentially, yes, correct. It's a fan to keep the cabinet cool. This is a smaller than 2.2 kilowatt unit, so it has an auto changeover inside. So it's not using the PV switching board. Okay, so I think we've got a picture there with one.
So there's on the 3-phase ones. Again, you've got your unit in the middle, the VSD. You've got your GPS unit there.
You've got your PV switching, which is the voltage detection board that you have there. And you got there your contactor, right? Which is essentially the same that we explained previously. So it's fairly simple to wire. I would say any competent electrician will be able to wire this quite easily.
It looks a bit scary, guys, but it's not that bad. We can do this for you beforehand, it's not a problem. But you're more than capable of connecting up something like this yourself. It's literally a positive, negative, positive, negative. It's not that difficult, guys. And we are here for support. If you do need anything, you can give us a call anytime.
So this is in more detail the usage of that PV switching board for the larger models. There is different part numbers depending on what size of BSD you're using. So essentially from 4.4, the title is incorrect, it's more than 4.4. From 4.4 to 15 kilowatts, you have that part number, the 055A. And from 18.5 kilowatts, which is the next inverter up size, you get the 110A. Okay, so now we're going to go to Chris again for the BPD series.
So this is one of the BPD series on the single phase units. So because it's having, because it's got an MPPT function built into it, it needs a lot less panels as well to start up. It's got a booster built into it. As you can see there, it's been fitted outside in elements. So it's IP65, it can be left outside. The setup of this unit is also very easy. You'll see in front there, it's got 3 little lights, and it's got a simple little configuration to set up. It's again very simple and very easy to put together, guys, not difficult. So the only unfortunate one with this is it's only for single phase. That's the only thing. It is compatible with the GPS as well, which is great.
It's a great unit, I will say, for any residential application. It's a great unit for any borehole pump for
out in the field,
for the field for cattle watering and these kind of applications, because it's all done for you. So it's no need to make a cabinet. You just hang it in there, and you plug it in, and it works. And it works with maximum efficiency because it has an MPPT and a PV booster. So this is a great little inverter for all those small applications. Actually, when you see how much it costs to get the GD100 to the same standard and the complexity and time, you probably would have been better just by getting a BPD originally.
Okay, there's just a BPD, the different models you can get, the different outputs. So you see the rated power there. If you go down, it says 8C output, rated power. You get 750 watts. It goes up to 6.6 kilowatts.
Very versatile, has many applications.
Okay, that's just a little view of what the VSD looks like, or the BPD unit looks like from the front. That's the bottom section. You'll see that you've got your AC output connector, which is literally again a plug unit. The comms for function terminals, which you can plug in your GPRS units. External keypad port, if you've got a little keypad for it. Your MC4 connectors, again, you just plug your panels in. Your AC inputs contactor, again. Very basic, guys.
Very familiar with the GD100. It's essentially the same nomenclature, S2 and S3 and S4 and S1. It shares the same functions. So you have familiarity between the two families. Depending on the size of the inverter, you can have one or you can have 2 inputs for the MPPT. So that can save a little bit of trouble as well. You can see that on the BPD2K2, actually do come with 2 inputs. The BPD004 as well comes with 2 inputs. And it's all pre-wired to actually have remote control with that's an important one. As you have seen, it's an IP65 enclosure. So there is no keyboard. So with the inverter comes an additional keyboard that you can plug on the bottom. That Ethernet looking connection, number 4, says keyboard. So the keyboard is not IP65. It's only there to actually do a setup of the inverter. Once the setup is done, you disconnect it and take it with you. The rest of the connections are all waterproof, including the connection to a GPRS module, which is waterproof. So the inverter can be hung under the solar array anywhere where you actually want to install it. As we discussed, it's single phase and 3-phase.
There's different kind of pumps, obviously, like we said, ball pumps, pool pumps, centrifugal pumps, depending on what you guys want to do. It's not necessarily only for pumps, guys. Anything that's got a motor. So if you've got a factory and you're running motors and you're driving presses or machines that are breaking up pallets or wood or whatever it is.
And you want solar assistance on it, this could be an alternative.
The great thing about the VSDs is it takes out your maximum demand spike of any pump or motor that starts up. So you start saving economically there with your electricity by installing the VSD.
Okay, so as we discussed, it has built-in AC bypass, so you don't have to worry about that one part. So the wiring very similar, if not the same, as the previous inverter. You will not find S1 because S1 is bridged internally inside of the BPD. So it's no need for you to do anything there. The same configuration for single phase 3 wire starts apply with connecting S4 to common and subtracting the capacitors. The same logic for the water control on the borehole and in the tanks applies. You have 2 digital inputs there. Actually, you have more than 2 digital inputs that you can use to control your pump inverter. The pump inverter uses S4 to actually have physical on-off for the pump inverter in this case. So you can have physical push button because there is no permanent keyboard on it. You want to have a button that you can go push on and off if you don't want to have it on full output. Okay, so that's what the function of S4 is in this case.
So again, the BPD with the lowest start PV voltage. The starting range is again from 80 volts because of the MPPT range. So you can see there at the bottom, the max DC voltage will be 450 volts, but the starting voltage will be 80 volts. So we're trying to always be a little bit more than that, trying to be about 100 volts minimum. The operating voltage between 80 and 250, as you can see there, and that equates to about 6 250 watt panels.
Or 300
300
watt
watt
panels for the small one.
Depending on the size of the BPD that you're using again. And you'll see on top there, you'll see a BPD 0K7, that's for the 0.75. The one will be 1K5, that's 1.5. The next one will be 2.2.
Correct.
Single phase units, yeah.
Correct. So if you're looking at 4 panels, that's 1.2. So looking at 1.5 times, that should give you about 4 hours per day, more or less, of pumping. So if you want more, you could add more strings to the maximum current, maximum input current that it can take.
So here's the GPS module that we were talking about. You can incorporate into your little system. Obviously, it works with SIM cards. It's already set up for South African networks as well as Zimbabwe. I think in Zim it's Eco.
In SIM we have
Econet, and SA it will be MTN. So you just put a little prepaid SIM card inside, and you load it onto your when you just plug it into your GPS module. You plug your module onto your VSD.
Correct, into a serial communication port or VSD. What this will do is that will give you access to INVT Internet of Things Cloud, which is the manufacturer cloud that manages the remote monitoring and remote control of all these devices. I need to highlight that there is control. There is a certain element of control and change on the behavior of the pumping system by using the app or by using the cloud. Okay, so the authorized installers will actually have an account into which they can register all their new GPRS modules, and then that will give automatic access via backend using your phone with your app. Correct. So the GPRS module is available on 2 different models. You can see a picture here. The first one is for the GD100. And then you have something that is exactly the same inside. It's just a dongle for the BPD module. It's just mostly to keep the IP rating of the device, right? Because it's a different type of IP rating. The benefit of the GD100, you can actually plug the antenna that comes with it. Or you can buy a bigger antenna if you want. If you're really remote, you can have an antenna with much more decibels than the one that it comes with. So it's as well, as we call the GD100, it's a more scalable type of product. So it could be used in many circumstances and customized. BPD is a more happy meal that actually does most of the things very well. So now I'll present you with the INVT Cloud platform. This is how it looks if you use your computer, your browser. That's actually the internet address on top. You need to have an account to be able to access this, an installer account. And then you have the app itself, which actually is native to the iPhones, the iStore, and to all the Android-based devices. Okay, so you have 2 versions. That's just snapshots from the Apple-based one, from the iStore one. Okay, so you can see you can actually do a number of functionalities on this guy. So you can change the flow rate, you can change the height at which the pump is pumping. You can obviously change the frequency. If you don't change the frequency, you cannot do any of those two. All from your cell phone, for as long as there is good communication, two-way communication between the pumping side and the cloud. There is more functions under development, but this is a great quantum leap. You can as well get faults. So if your pump motor is failed, if your borehole is dry, if your tank is full, etc., etc. So I'm going to just show you that now. So to the left, you can see all the pumps have been associated to the profile of this person on the app. So it's about 4 or 5 there. Then you have historical faults. You have statistics of the distribution of different faults that have been experienced by the system, etc., etc. So for simplicity, we have just included on the presentation the QR codes for downloading the apps, both on the App Store and in the Google Play Store. You do require an account that needs to be opened before you can actually have access. The account is not self-registration. So we have to assist you to actually create that account. As we said, we have stock on hand at the moment with modules which are programmed for GD100 for SIM and for South Africa. SIM Econet, South Africa MTN. Any other country can be programmed. It's not a problem. It's just that the programming tool required to program the cell phone modem chip inside is quite expensive. So we bring them from the factory pre-configured to a specific network. We are not an electrical wholesaler that sells every single element that you can buy. AC component that you will need for this. But we do sell all the DC protections that your system will require. We're able to supply all of that. Your SPDs, your fuses, your DC isolators, and all those kind of things.
It's just a breakdown of which model, what AC side breaker you need, DC breaker. We can help you on the DC side. On the AC side, it's more easy just to pop into AC/DC Voltex, pick up exactly what you need. But there's a little breakdown of what you'll exactly need for each VSD.
100%. The documentation is beautifully put together. It's in good, well technical English.
Very easy to read.
Very easy to read. And equipment is easy to configure. All the information that we have presented to you today actually is available in every single one of the manuals of equipment. Okay. So now let's talk about a couple of things, right?
So as we were speaking earlier about depth.
Cable length more than depth, I would say. So cable length.
Your cable length and also, obviously your depth as well. So depending on your cable length that you have, your VSD will take power in and obviously bring power to your pump. But it's distorted at a certain point of distance. So anything from, as you can see there, from about 25 meters and more, we always suggest that you fit a reactor or a choke. It's almost like a transformer that just cleans out the electricity coming out in the output. So any distance from 25 meters plus, anything less, well, 25 meters plus and less than 100 meters, you're looking at fitting a reactor choke, just to clean out the power to get it to your motor, so you don't damage the motor at the end of the day. So these things, again, they're not very pricey, guys. They are quite cheap.
But they're necessary.
And they are necessary. You don't want to damage the equipment that you have on the output.
So essentially, what is this choke? It's essentially a one-to-one transformer, so it's an inductance. In the picture that you have there, you have a picture for a three-phase system. There is no, even though it's a three-phase system, you don't need one on neutral, so it's only on the live phases. What the inductor does, it's actually not refuses, but rejects quick changes in current going through it, or dampen them, because we're using a very fast switching method. We use PWM to go from DC to AC, that generates ripple on the current that is going out, which you can see on the top chart. So depending on the length of the cable, you can create bouncing of this ripple in between the motor and the VSD. In certain situations, that bouncing can have the ripple coming back from the motor can superimpose to the ripple coming out of VSD, therefore start increasing and increasing those peak voltages coming out of VSD. So that will be seen on the motor as a high frequency sinusoidal high voltage wave, and that creates overheating into the motor. So that's why it's a very long cable with a very big possibility of having this amplification of the ripple. It's recommended to have this filter, or this reactor, which is typically called an inline reactor choke. Yeah, there's a long explanation to what this, which you said.
Little breakdown.
Little breakdown on it. Then you can get more sophisticated, and then you can have a sine wave filter, which essentially is choked with a capacitor bank. To a certain extent, if you enable the onboard capacitors on certain of the pump inverters, you will only require to have the choke. But in certain applications, depending on the length and diameter of the cable, you might require a sine wave filter, which is essentially a reactor with a capacitor bank.
Usually based on more than 100 meters.
Usually much longer than that, correct? Because now the capacitance inside of the inverter is not enough to work as an effective filter, because the ripple actually grows a lot bigger, correct? So a few examples of installations done in Africa with this equipment. So this one is before they finish. This is a very interesting one. It's a feature that we didn't speak about, but I will explain. The inverters can be set as master slave. So you can actually run those 4 pumps as essentially one pump station. You will see that there is pressure sensors right on top of all those loops coming on the discharge of the pumps, and so is one on the manifold. So the signals actually can be used as well to control the pump inverters. So we can have a pump station essentially. Each of the pumps is an individual system as such. It's a pump inverter with some boxes, some switching kits, but all of them communicate via serial and a master-slave configuration. So you can make very large pumping stations by using these. Up to 4 pumps can be controlled with this. That's what you see there, 4 pumps. Okay, so up to 4 pumps can be used. The biggest inverter that can be made is actually 200 kilowatts. Yeah. So that will put the maximum pumping station size at the moment at 800 kilowatts, which is a very large,
massive pumping
station. There is a few more pieces of equipment that will be required. There will be required a PLC and a few more things to be able to capture the data and do something smart on such a large pumping station, right? But it's all possible. It's built into equipment, the capability. Now we go from those very big systems into something smaller. You will see, I mean, some people don't buy the IP65 box. They're going to install this indoors. What you have there in the picture is your three-phase pump inverter. You have a GPRS module to broadcast from the internet. And you have a choke. Okay, so basic installation, you have your protection on top, circuit breaker and surge arrestor. And we have the same version, but now a little bit nicer, neater. Here we have AC input. As you can see, we have actually a contactor. We have the switching board there, which is to the left. It's a shiny piece with the electronic board. And we have our inverter and our PV input, which is in the bottom left. You can see there the two fuses, okay? There is even a timer as well. And that timer is the contactor, so you don't run the pump all the time. So this is a good example of a nice installation made with a larger three-phase pump inverter. And that's it for today, guys. So Chris and I here are very grateful of your time.
Thanks for your time, guys.
We have time.
If there is anything you guys need, if you guys need any technical information, if you guys need us to help you size any systems, give us a call, drop us a mail. We're always available, guys. We'll help you as much as we can. If you've got information for us, we can help you wherever we can, guys.
Please, all questions direct to sales@easypowersolar.co.za. We'll be more than happy to go and answer them. And stay tuned for a few more upcoming webinars that we are planning to have during this period of lockdown. Thank you.
Stay safe, guys, and be careful. Cheers, man. Thanks a lot.
Cheers, sir. Bye-bye.